7.2. Show that RS is equal to 2Q tan beta divided by P sine alpha. So we're looking at RS, which is this. That's what we're looking for. And then RS equal to 2Q tan beta. So we have to bring in angle beta there. Right? So we have angle beta, which is this. Which triangle should you use here? We should use triangle RSK. RSK, because with triangle RSK, we can have the side RS and angle beta. Remember, we have our what? Side SK, which is this. So this side SK is the one that is going to bring the Q and the P and the sine alpha. And then beta here, what is the size of this angle? What is the size of angle RKS? It will be beta. Remember, we have the angle of depression and then the angle of elevation. The angle of elevation and the angle of depression are equal because they are what? They are alternate angles, because these two are parallel. Okay, so angle RKS is also beta. Now, if you look at triangle RSK, this is a right angle triangle. So think of the Pythagoras theorem. Think of the simple trig ratios. Tan beta, sine beta, cos beta. But if you look at the reference angle and the side we are looking for, RS is the opposite side, and then we have SK, which is the adjacent side. We want to use this SK. It is the adjacent side. So we can use tan beta, which is the opposite side, over the adjacent side. So it's going to be RS over SK. And make RS the subject. So RS is equal to SK times tan beta. Now we have brought the tan beta, if you check here. And then this is SK. We can bring in this. Where there's SK, we put 2Q over P sine alpha. So RS is equal to 2Q over P sine alpha times tan beta. This tan beta. Right. So we've managed to prove that RS is equal to 2Q tan beta divided by P sine alpha.